Okay, this test is tomorrow, and then we'll start in on Chapter 6 on Wednesday. Unless we don't have school tomorrow, and then the test is Wednesday.
Why wouldn't we have school tomorrow? It's very snowy out.
We're under a winter storm warning tonight and tomorrow morning.
We should all do like a little break thingy that we don't have school.
I agree.
Me and Sheridan already played this one.
Mr.
Okay.
Yeah, would I be able to come in, or would I be able to run home after school and then come back in and get help on the poster?
I'll probably count 10% off
Okay.
because, I mean, it's due today, so you should have gotten help Friday when I told everybody to get all their work done and turned in Friday.
Okay.
Okay. So let's go with the first one. Solve the quadratic equation by factoring. The fact they tell me to solve it by factoring lets me know that they're both factorable. Okay? And they're both factorable using the techniques we learned in section 2, which was the special factoring techniques. The first one's a difference of two squares. So to factor a difference of two squares, you take the square root of both, write it twice, and you notice there's no middle term. The reason is this is positive, this is negative. That's the pattern for difference of two squares. And now I'm going to set those equal to 0 and set each factor then equal to 0. And then solve. So x is either negative 5/2 or positive 5/2.
Is it okay to do it like the bottom template? I don't think by taking
Like by multiplying 4.
Yeah, I suppose. But, I mean, this is much faster. And if you guys can learn the patterns, you're going to save yourself time on the ACT. If you just do everything bottoms up, it'll be slower. That's why we had a whole section on the special factoring rules. Okay, this one's also special factoring, but before you can factor it, this term, the x squared term, always must be positive. Okay, so we've got to factor out a negative 1. And now we're looking to factor, and this is another special factoring technique, when both ends are perfect squares. You take the first term, the square root of the first term, and the second. The sign in between them is the same sign as the middle term. And then you can just check it because this is the same thing as 3x minus 2 quantity squared. And the way you FOIL this quickly is you square the first term to get 9x squared, square the last term to get 4, multiply these together times 2 to get negative 12, so we know this is the correct factoring. Okay, we're going to set that equal to 0. When we divide both sides by negative 1, it's still equal to 0. And then take the square root, we're still equal to 0. Only one solution, it's 2/3. So if we had looked for the discriminant of this quadratic, the discriminant would have been equal to 0, because if the discriminant's equal to 0, there is only one real solution. Okay. Next, write the expression as a complex number in standard form. So this is not multiplied, this is subtracted. So the first thing I'm going to do is distribute the negative 1 to both terms. Combine my like terms. Negative 5 plus 4 is negative 1. Negative 8i plus 8i is 0, but it wants it in standard form as a complex number. So to get full credit, you need to write it as a complex number in standard form with 0i. Next one, we have an I in the denominator. The I is a radical. You don't have radicals in the denominator, so we have to get rid of it by multiplying by the conjugate, top and bottom. Okay, 2 plus I squared, which is what the numerator is. Square the first term. Square the last term. The middle term is this times 2. I squared is negative 1. 4 minus 1 is 3. So there's your numerator. Your denominator is a difference of two squares, so it's 4 minus I squared, no middle term. That positive and negative sign forces the middle term to drop out. I squared is -1, so it's 4 minus -1, which is 5. So there's your answer. If I were to write it in standard form, it looks like that. All right. Next ones just say solve. There's no middle term, so I don't need to set it equal to 0 and factor or use the quadratic or complete the square. All I need to do is subtract 1, divide by 2, and take the square root of both sides. X equals plus or minus the square root of -8, and I'm not done. 8 can be simplified, and the negative sign can be taken out. 8 simplified is 2 squared roots of 2. And the negative just means I add an I to it. So the answer is plus or minus 2 squared roots of 2. All right, next. Same issue, I don't have a middle term, so I can just subtract the 1. Multiply both by 4, that's 128. And then x is equal to plus or minus the square root of 128. And my biggest perfect square that goes in there, 64. And there's my answer. Next, completing the square. If I'm solving by completing the square, I'll be talking more about this in number 8, but when I'm solving by completing the square, if you want to divide that leading coefficient but through by everything, that's fine. If I'm trying to get it in vertex form, I just want to take that leading coefficient out of the left side because I need to have that A still there. Okay, so make sure you understand the difference. Solving, I can divide everything by the leading coefficient and I'm done. But if I'm going to put it in vertex form, go ahead and move the constant over and then just factor that leading coefficient out of the left-hand side. Okay, so the first one, there is the leading coefficient's 1, so I'm pretty safe here. So I take half, which is 1, square it, 1, add it to both sides, factor. I'm solving, so I'm going to take the square root of both sides. This is 3i. And then I'll add 2. 3i. Okay. Next, again, I need to get everything to one side first. Move my 3 over. I'm going to go ahead and divide everything by 2. Half of this is 9/4. 9/4 squared, 81/16. This factors. And again, a denominator of 16, I need to multiply top and bottom by 8. Is that right? 24 plus 81 is what, 105? Okay. Then I have x plus 9/4 squared equals 105 over 16. Square root of both sides. Square root of 16 is 4. Then subtract 9/4. I don't think I can simplify 105. Okay, use the quadratic formula to solve these. So first step is always to put it in standard form. Identify A, B, and C, and then put it in the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. 3 plus or minus the square root of 9 minus 20, negative 11. So I'm not quite done. 3 plus or minus the square root of 11i. Okay. Next one, again, I need to make sure I put it in standard form first. Because I'm solving, I can just divide everything by 2. Identify A, B, and C, and then put it in. B squared is 16, A is 1, C is 8, and all over 2. 16 minus 32 is negative 16. So that's 4 plus or minus 4i over 2, which is 2 plus or minus 2i. Okay. All right, graphing. First one is y equals x squared plus 2. So if I were to put this into the general form, this would be a good exercise to identify what A, H, and K are. What is A? 1. What is H? Zero. What is K? Plus 1. So this is going to look like the regular y equals x squared graph, shifted up 1 unit. So my vertex is going to be at 0, 1. Okay, and if I'm just looking at y equals x squared, because I know it's just this function shifted up 1, when x is 0, y is 0. When x is 1, y is 1, and negative 1. When x is negative 1, y is 1. When x is 2, y is 4. 1, 2, 3. Yeah. So this is the graph of y equals x squared. So my graph of y equals x squared plus 1 is just this graph shifted up 1 unit. So all these points then just get shifted up. So there's the graph of y equals x squared plus 1. Questions on that? The next one's in standard form. So in standard form, what points do I know just looking at it? Nope. Y-intercept. Just looking at it, what's the y-intercept? Negative 5. Negative 5, 0, 1, 2, 3, 4, 5. There's my y-intercept. How do I find zeros? What's that? Yeah, I'm going to set this equal to 0. And how do I do that? How do I solve for x? I can try and factor it. Is it factorable? Yep, I can either complete this, not factorable, so I'm going to either complete the square, use quadratic formula. I can choose, I'm going to use quadratic. negative b squared minus 4ac all over 2a. So it's 2 plus or minus the square root of 4 plus 20 is 24 all over 2. Square root of 24 is 2 square roots of 6. So it's 2 plus or minus 2 square roots of 6 all over 2, which then is just 1 plus or minus the square root of 6. Right? So I'm just going to take a calculator. 1 plus the square root of 6 is 1 plus the square root of 6, 3.45. So it's going to be here somewhere. 1 minus the square root of 6 is negative 1.45. 1. So there are my zeros. Okay. Axis of symmetry. What's the easiest way for me to find it? Negative b over 2a. Negative b over 2a. So negative 2, negative b would be positive 2 over 2a is just 1. Axis of symmetry is here at 1. Vertex is going to fall on there somewhere. All I have to do is plug in 1 for x's and solve for y. 1 minus 2 minus 5 is negative 6. 2, 3, 4, 5, 6. So there's my axis of symmetry, or my vertex. So now I can just move this y-intercept over the axis of symmetry, and I've got 5 points. And there is my parabola. It opens up, which makes sense because the coefficient in front of the x squared term is positive. So that's how we graph it if it's in standard form. You've got the y-intercept. You find the vertex with negative b over 2a. Plug that back in and find the y-coordinate of the vertex. And to find the zeros, you either factor, use the quadratic formula, complete the square. Okay. The next one, they give it to us in vertex form, or in intercept form. So what do we know just looking at it? What's that? What points? No, not the vertex. This isn't vertex form. X-intercepts. Or x-intercepts. Or the zeros. That's what factored form or intercept form gives you. Negative 1, positive 3. Those are my intercepts. I know this parabola points what direction? Down. I can find the axis of symmetry really easily by just averaging these 2 points, which puts it in right there at x equals 1, or finding the midpoint. So I know my vertex happens along the x-axis, or the x-axis of symmetry, which is at 1. So I'm just going to plug 1 in for x here, 1 in for x here. So y is equal to positive 4. 1, 2, 3, 4. There's my vertex. To find my y-intercept, all I do is plug in 0 for x. 0 plus 1 is 1. 0 minus 3 is negative 3, so it happens to be at 3. 1, 2, 3. I can mirror that over the axis of symmetry, and now I have my parabola. It points down, which it should, because the leading coefficient is negative. Okay? If it was given to me in vertex form, I'm given the vertex just by nature of looking at the form. Right? Given the vertex, to find the y-intercept, just plug in 0 for x. To find the 2 x-intercepts, solve the equation, set it equal to 0, and solve from vertex form. And then you'll have those points. Okay? Questions on graphing? All the steps you did for your poster were finding all of these points so that you'd be able to graph. You found the points in standard form, you found all the points you needed in vertex form, and you found all the points you needed in intercept form. That was the whole idea of going through that process, so you would be able to graph. All right. Next problem is discriminants. Remember, the discriminant is this formula, which happens to be what's under the radical of the quadratic formula. Do not just plug it into the quadratic formula and solve. That's not what it's asking. It wants to know the discriminant. Discriminant is b squared minus 4ac. So first thing I need to do is get this in standard form. B squared, that's 25, minus 4ac. 25 plus 96 equals 121. So this discriminant is 121. Because it's positive, it tells me that there are two real solutions. That's what it wants you to answer. The discriminant, two real solutions. Okay. Next one, same process. First, I need to get it into standard form. B is negative 3. That's 9 minus 4ac. 9 minus 32. Is that right? 8 times 4, yep. Which is negative 28. 4ac, yep. No. Thank you. Try that. Negative 23. Because it's negative, it tells us there's two imaginary solutions. Questions on that? So all you need is b squared minus 4ac to solve those problems. Okay, graphing inequalities is the same process that we've gone through when we did equations of lines or absolute value functions, but now we're dealing with quadratics. So you graph it the way you normally would an equation, and then you have to remember two additional things. Is it solid or dashed? And where is it shaded? Okay? So first one will be solid, second one will be solid. So I don't have to worry about dashing anything because they're both or equal to. Right? So I'm just going to graph the first one. 2x squared minus 1. Well, this is the graph of the regular function x squared stretched by a factor of 2 and shifted down 1. Okay? But if I want to write it in general form, minus 1. That's what it looks like. So what is the vertex? 0, negative 1. What else could I do here? I could find the two zeros. That's a squared. 2x squared equals 1/2. X equals plus or minus the square root of 1/2. All right? So square root of 1/2. 0.707, which is a little less than 1. This one's a little less than 1. So not what I'm trying to graph it. I just want approximate decimal value so I know where it's at. So it's negative 0.707, positive 0.707. My y-intercept is my vertex, so that's not going to give me anything else. So I just need to find two more points. So I'll just plug in 1 for x. When x is 1, y is 1. So if this is my axis of symmetry, there's another one. So I've graphed it. Now I just have to decide where it's going to be shaded. And I can use the point 0, 0 because it's not on my graph. So 0 is less than or equal to negative 1. True or false? Is 0 less than or equal to negative 1? It's false. So 0, 0 is not a solution. So outside of this is a solution. Okay. Next one, they give it to me in standard form. So to graph in standard form, I can either try and factor, which this one looks pretty easy to factor. What are the factors? Which one? 6 and 1 or 2 and 3? Negative 2, negative 3, negative 2, negative 3. 6 and 1, they both can't be negative for me to get negative 5. And they have to both be negative for me to get a positive number. Okay, so if I do this, I can see right away my intercepts are 2 and 3. I know my axis of symmetry then happens right in the middle at 2.5. My y-intercept is at 6. 1, 2, 3, 4, 5, 6. So I can mirror that over and find one more point. So really all I'm missing is the vertex. Right? And to find the vertex, I just plug 2.5 or 5 halves in for x and solve for y. So 5 halves squared minus 25 halves. Putting in 5 halves here. 5 times 5 is 25 over 2. Plus 6. So we've got 25 fourths. To get this into fourths, I have to double this. To get this into fourths, I have to multiply this by 4. 25 minus 50 is negative 25. Plus 24 is negative 1. So it's negative 1/4. That sits right here on the axis of symmetry. And now I can graph it. I can use 0, 0. So I'm going to plug in 0. 0 is greater than or equal to 6. True? False. Okay, 0, 0 is outside, and that's false. So I'm going to shade everything inside. Okay, so it's the same as graphing quadratics with 2 things you have to remember. Solid or dashed, and where is it shaded? Questions on that process? Okay. All right, next problem, vertical motion. A football is released into the air at an initial height of 9 feet and an initial velocity of 30 feet per second. The football is caught at a height of 10 feet. Use the vertical motion model, which they give us, where h is the height, t is the time in motion, s is the initial height, so s is 9, and v is the initial velocity, so that's 32. So that's my equation. It wants to know how long the football is in motion. It says it's caught at 10 feet. Is this parabola going to open up or down? Down. And I know the y-intercept is 9. How do I know that? Because it's the constant, and they told me it's released into the air, which means time equals 0, at 9 feet. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. There's the initial where it's released. It's going to go down. And it's caught at 10 feet. So someone catches it there. So it's going to have some kind of shape like this. Did everybody see that? Okay, because it's got to be a parabola that opens down. Okay, so imagine someone releases the football at 9 feet in the air, and someone downfield is catching the football. Maybe they jump to catch it at 10 feet in the air. Okay, and they're wondering how long that thing's in the air. Well, this is time, and this is height. They tell us that. This is x, this is y. Okay, so the time it's in the air is from time equals 0 to time equals 10. Or sorry, till the height is 10 feet, right, which is down here at some unknown time. It's going to equal 10 feet on the way up as well, right? So I know I'm going to have 2 times it hits 10 feet. One is going to be a shorter time. One's going to be the longer time. The longer time is what I want, because I want to know when it was caught, not when it hit 10 feet on the way up, right? So what I need to do is just set this height equal to 10, solve this quadratic, knowing I'm going to get 2 answers. Whichever answer is the biggest is the one that's the right one. Does everybody follow that logic? In order for me to do problems like this, that's my process. I have to graph it, even though it's not a perfect graph. I just need to sketch it so I really understand what the problem is and what they're looking for. Okay? If you don't do that, then you're the kind of person that looks at these and says, it's a word problem, I give up. Well, they're very possible to solve, but you just need to sketch yourself a picture, go through the process of saying, what do they really want, and how am I going to get that answer? Okay, so that's the process I just went through with you, is the same process. I don't jump into these problems and be able to solve them in my head. If I can't do it, you can't do it either. You guys have to get in the habit, when you see word problems, just writing down what you know and asking yourself, what do they want, how am I going to get it? Okay, so I've kind of got the sketch. Here's my equation. Well, how do I solve quadratics? I set them equal to 0. So negative 16t squared plus 32t minus 1 equals 0. So this is the equation I need to solve. Do I know how to do that? Yeah. I could sit here and try and factor it, or I'm just going to jump to the quadratic formula. Sometimes that's easier. Okay. Negative b plus or minus the square root of b squared minus 4ac all over negative 32. At this point, I'm just going to do this. 32 squared minus 64, right? Negative 4 times negative 16 times negative 1 is negative 64. That's 960. So I'm going to take negative 32 plus the square root of 960, divide that by negative 32. I get positive 0.03. Or I take negative 32 minus the square root of 960 divided by negative 32. I get positive 1.97. Well, there are my 2 times. The first time it happens 3/10 of a second after I released it, which makes sense. It was on the way up. The second time it happened when it was caught, which was almost 2 seconds after I released it. Okay, and how long the football is in motion? 1.97 seconds. This is an application problem. This is why we study quadratics, so you can actually answer questions like this. Okay, number 19. Write the following quadratic function in vertex form. Well, anytime you see vertex form, you know you've got to complete the square. So I'm going to complete the square by setting it equal to 0 first. Take half of this, which is 2, and square it. Now I want to get it back into a y equals. So I'm going to subtract the 10. and now it's in vertex form. Okay, so the only one that's x plus 2 minus 10 is this one and this one. So now it's the question of what's the axis of symmetry. Well, the x-coordinate of the vertex is what? Negative 2. So my axis of symmetry happens at x equals negative 2, which is letter A. Questions on that one? Okay. Last one. Write an equation for the parabola whose vertex is at 3, 3 and which passes through the point 5, 27. Well, if they give me the vertex, I need to use vertex form. If they give me the intercepts, I need to use intercept form. Okay? Vertex form looks like that. So all I need to do is plug in the vertex for h and k. Minus 3. And plug in the point they give me for x and y. I always do parentheses first. So that's 2 squared is 4 times a is 4a. Add 3. Is it not? It wasn't. Sorry, this is positive. Sorry. Subtract 3 then becomes 24 equals 4a. So a is 6. Does everybody see that? A is 6. So I'm just going to plug it right back in here. And I have my equation in vertex form. Okay. If they wanted it and they gave it to you in, they gave you the intercepts, they're going to give you 2 intercepts. This is probably what's going to be on the test tomorrow. They'll give you 2 intercepts in a point. Okay, so you're going to plug it in to this form. Right? Plug your intercepts in here and here. Plug in the value they give you for x here and here, and y here. Solve for a, and then rewrite it the same way. Okay. Anyone need any kinds of problems reviewed that we've gone through? Test is tomorrow. You should have, you all, I feel like, have this down pretty well. Okay. Especially after doing the poster and going through all that work. Okay. So if we have no school tomorrow, I told second period I'll add a point to the test. Just for fun. And then the test will be Wednesday. They wanted me to cancel the test altogether. I said, no, how about if I just add a bonus point to it? Okay. We didn't have a quiz over the last 3 sections. We just had the poster. So if you do the CK12 over the last 3 sections, that gives you an extra 10% on the test. Okay, so get that done tonight if you can do that. I'm recording, so if you need to watch this again, watch that tonight to be ready for it. Remember, the posters are due at the end of the day today. And anything after that, I'll just take 10% off. And that will go in as your last quiz grade for the chapter. Okay.